Our new entry is on finding cube roots, so very similar to square roots. If we take a look at our notes for square roots, we go back. So a square root of a number is a number that when multiplied by itself equals the given number. And we went over some perfect squares. So the square root of 4 is 2, because 2 times 2 gives you 4. 3 times 3 gives you 9. 4 times 4 would give you 16. So the square root of 16 would be 4. When we start talking about cubes, okay, a cube root of a number is a number that when multiplied by itself and then again by itself equals the given number. And then a perfect cube, similar to a perfect square, is a number with an integer as its cube root. So let's give an example here of a cube root. So this is going to be a perfect cube. Okay, the cube root, and how we denote it is, this means cube root. Okay, square root we usually just don't have to put in the symbol here. Cube root, we have to show it, right? We have to show that this is the third root. So the cube root of 8 is equal to 2, because 2 times 2 times 2, right, 3 of them, or 2 to the third is 8. So 2 times 2 times 2 gives me 8, therefore the cube root of 8 would be 2. And we're going to do the same thing we did with perfect squares. You're going to list them off just like that. We just did 2. This is the cube root of 8. Now the cube root of what number gives you 1? The cube root of what number gives you 3? So in order to find out that number, you're going to do 3 times 3 times 3, which is 27. So the cube root of 27 is then 3. So you're going to do the first 10 integers on the perfect cubes for those integers. And then on the right side, I'm going to show you what we're going to do after that. But first, fill in for the first 10 perfect cubes. So this should be your list of the perfect cubes. Now I want to talk about something that we can't really do with square roots, but we can with cube roots. So what if I wanted to find the cube root, instead of positive 8, what if I wanted to find the cube root of negative 8? Okay, I'm going to do my negatives in red. So what number multiplied by itself 3 times could give me negative 8? And let's think. Well, it can't be 2, because 2 times 2 times 2 gives me positive 8. So what about negative 2 times negative 2 times negative 2, or negative 2 cubed? So negative 2 times negative 2 is 4, times another negative 2 would give me negative 8. So the cube root of negative 8 is negative 2. It's its negative version. Okay? So now what I want you to do is go through all the negatives. And this should be pretty straightforward. We just found the cube root of negative 8 is negative 2. Positive 8, positive 2. Negative 8, negative 2. Alright, so these are just the negative versions. So go through and make that list. And that should be your list right there of our positive cube roots and our negative cube roots. And what we're going to do next is we're going to do some evaluating expressions with negative and positive cubes. And now we're going to go through a couple examples. So we're evaluating each expression. So this is 2 times a cube root of negative 216 minus 3. Now, when we use order of operations here, we start with parentheses, right, PEMDAS, and then we go to exponents. Cube roots, if you remember, are the same as exponents. We have to do that first. A cube root is actually an exponent of 1/3. So it's an exponent of a fraction. You'll learn that in Algebra 2. So the cube root of negative 216. If I flip over to my other page here, where I went over my cube roots, negative 216 would give me negative 6, because negative 6 times negative 6 times negative 6 is negative 216. So now I do this one step at a time. I've got 2 times negative 6 and then minus 3. 2 times negative 6 is negative 12 minus 3. Negative 12 minus 3 is negative 15. So there's that one. Now let's evaluate this one here. So cubing something, right, and taking the cube root, those are opposites of each other. So anytime you see this, right, the cube root and then cubed, those are opposites. It's like multiplying something by 2 and then cutting it in half, or doubling something and cutting it in half, right? Those cancel each other out. So I can actually do that here. Those are opposites. I want you to write that in. So now I just have 125 left. Plus 21. And 125 plus 21 is 146. On the left side of your book, I want you to do the following 6 problems. For our last example, we're going to evaluate this expression when x equals 192. So we have x divided by 4 plus the cube root of x divided by 3. So let's evaluate that expression. We know that x is 192. Okay, that's what they give us. So everywhere I see x, I'm going to substitute in 192. So instead of x over 4, it's 192 over 4. And it's plus the cube root of, well, it's not x over 3, it's 192 over 3. And then I can just keep on evaluating. 192 divided by 4 is going to be 48. Plus the cube root of, what's 192 divided by 3? And that's 64. So the cube root of 64. Now, what is the cube root of 64? If we look at our list, 64, cube root of 64 is 4. We go back to my page. This becomes 48 plus 4, which is 52. And there you have it. On the left side of your book, I want you to do the following 2 problems. Those are some examples of cube roots. You're going to do the on your own problems and the practice problems, and then move on to the textbook practice.